All right, hopefully this video goes better than the one I did for Algebra 1. My geometry students are going to be introduced into trig functions, so sine, cosine, and tangent. All right, so we have sine, cosine, and tangent. This symbol right here for my students, they've never seen it before, that is a Greek symbol theta, and we are going to use it to identify an angle. All right, so I'm going to come in here to this right triangle, and again, trig functions, we are going to be doing these only on right triangles. They are for right triangles. All right, so I'm going to put theta there. That means that I am talking about that angle. That is the angle that we are going to base these functions off of for this problem. All right, so this will be the first example. Something I want to make my students watch is I can't make them because they're all at home. If they were in my classroom, I'd make them watch it and make them sing it. It's a really annoying video I found. I don't remember, I haven't watched it since last year when I taught this, but it's just this guy that keeps saying SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. All right, SOHCAHTOA, SOHCAHTOA. Need to have that memorized. Geometry students, by the end of the year, should have this memorized for the rest of their life. SOHCAHTOA, 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 SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I love when I finally give out a test or an assignment and I see students popping off, SOHCAHTOA, 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 and they're doing it in their head. It's awesome. All right, it's so annoying that it's just ingrained in your head. All right, so to understand this, we need to go over the types of sides that you will have. And these depend, all right, these are dependent, depend on which angle we are going. All right, now this one doesn't depend, but that one and that one, those guys depend. Hypotenuse never changes. Hopefully from the last video doing the Pythagorean theorem that everybody knows that the hypotenuse is always the longest side. So this is always going to be the hypotenuse. All right, that is always the hypotenuse. It is directly across from the right angle. It's the longest side of a right triangle. Where's my eraser at? All right. But these two, this one and this one, depend. They depend on where this is. Because if I'm going to do the opposite side, opposite, are these two sides opposite or are they touching that? I feel like they're touching. They're making the vertex of the angle. All right? They're touching right there and they're touching right there. They make the vertex, they make the angle. Opposite would be over here. So this would be opposite, which makes this one adjacent. Now, some students always ask, well, isn't hypotenuse also adjacent? You know, adjacent, remember the definition of adjacent means next to, close by. When we're talking about angles, it means it is one of the sides that makes the angle. So yes, this is also adjacent, but it's the hypotenuse that overrules the other, all right? This is more important than this is being adjacent. So this is adjacent, this is opposite. This is always the hypotenuse, no matter what. Longest side. So that's where this SOHCAHTOA comes in, is If I give you a problem that says identify what sine of the angle would be, well, opposite over hypotenuse. Opposite over hypotenuse. All right. So let's actually give some numbers and solve this. An easy one is a 3, 4, 5. That's a special right triangle. So opposite over hypotenuse. So this would be opposite, which is 4, over the hypotenuse, which is 5. That is the answer. All right. Cosine, ca. So ca, adjacent over hypotenuse, would be 3 over 5. That's the answer. All right. And then tangent, toa, opposite over adjacent. So opposite over adjacent. All right, so those are going to be the types of problems that my students get. So now I'm going to make a new triangle though, because I want to show you how it all depends on where black marker. Well, depend on which angle we're going from. So if I redraw that, all right, and I put theta down here. Now we're talking about this one. All right, still got our 3, 4, 5. I don't know why I erased all that, to be honest. I just made more work for myself. This is the hypotenuse, always the hypotenuse. However, the opposites and adjacents just switched, because now this is the opposite and this is the adjacent. They flip-flopped. So if we're going from here, that's opposite, but when we're coming from here, that's opposite. All right. I highly suggest my students to always do this opposite first or adjacent. I mean, it depends on how people's brains work. I know sometimes geometry is hard because some people have a hard time seeing structure in diagrams. All right, so these answers are going to end up being different than what they were last time. So when I do sine of that angle, instead of being 4/5, it's 3/5. And instead of being here 3/5, it's 4/5. So they flip-flopped. And instead of being, what was the last time, 4/3, now we're going to have 3/4. Because we're coming from the other angle. All of them just flip-flopped. All right, flip-flop, flip-flop, flip-flop. When you flip, or when you go from the other angle, you get the reciprocal of the ratios. All right. I don't want to say reciprocal. This one's a reciprocal. Sorry, this one's reciprocal. These two don't flip-flop. This top one just switches. So when you go from this angle to this angle, I'd switch them back. This would be 3, this would be 4. When I'm talking about this one's 3, this one's 4. All right, hopefully I didn't just confuse my students. So I'm gonna quickly do just some quick examples for the types of problems my students are gonna get. So let's draw some quick triangles. And I'm gonna give them, I don't even know if this works, 8, 10, that would make this the square root of 164. I'm making it work. Okay, so we got theta. That means I'm talking about here. There's my right triangle. I'm gonna ask them to identify, I don't know, let's say sine of theta equals what? So sine of theta. SOHCAHTOA. So opposite over hypotenuse. Opposite over hypotenuse. So I'm going to come over here. Opposite. So 10 over square root of 164. That's it. All right, and then if I asked them to find the cosine of theta, cosine, adjacent over hypotenuse. Okay, adjacent over hypotenuse. Well, that's still the hypotenuse. Hypotenuse is still the square root of 164. And by default, if this is opposite, that's adjacent. And again, it's adjacent because it's touching right there, right? The side touches right there. So 8. All right, and then if I wanted to find the tangent of that angle, then that is TOA, opposite over adjacent, so I get 10 over 8. And my students better simplify that. 5/4. 10 over 8, 5/4. All right, we're good. And I know technically, because of the school closure, I'm not getting into simplifying this. I would have, if my students were in my classroom, gone over, we don't really like square roots to be on the bottom of the fraction, and we'd simplify that. But for the sake of this, I just want my students to understand that which one goes where, and that's it. Opposite goes on top, hypotenuse goes on bottom. All right. One last example, and we're gonna call it good. Let's do an upside down triangle. Let's do an upside down triangle. Let's call this 3 and 3. I don't know off the top of my head. I'm just gonna use 10. It's easy to work with. That ends up being the square root of 109. Okay, so let's grab a different color. So we're gonna talk about sine of theta, sine opposite over hypotenuse. So that equals opposites over hypotenuse. So 10 over the square root of 109. All right, cosine of that angle equals adjacent over hypotenuse equals adjacent, right? We're touching right there, so this is adjacent. 3 over the square root of 109. And then we got tangent. To solve for this, tangents, we got opposite, TOA, opposite over adjacent, so 10/3. So opposite over adjacent, 10/3. All right, that's what my students need to be able to do, and I hope this video helped them, and I hope it helped you. Thank you for watching.